Now we will look into integration of rational functions. So we learned about rational functions in semester 2 when we did partial fractions. So when you have when you need to integrate a function that looks like this, okay, 1 over x squared minus 3x plus 2. So your first step will be study the function. So obviously you can't integrate this directly. There's no formula taught to you because it's an x squared at the bottom. So your first step will be you factorize the denominator. Okay. Once you factorize the denominator, then it's very clear that it's actually you need to find the partial fraction for this. So it's a over x minus 2 plus b over x minus 1. Please work the partial fractions on your own and you will arrive to 1 and negative 1 being the a and negative 1 being the b. Next, you need to integrate both of these functions individually. So obviously integrating 1 over a linear function gives you a ln. So integrating 1 over x minus 2 will give you ln x minus 2. And integrating 1 over x minus 1, the minus was already there, it equals to ln of x minus 1. And because this is an indefinite integral, therefore you need to add a c to your final answer. You can also write it in another form where you let c to be ln k, and therefore your resultant will be ln x minus 2 minus ln x minus 1 plus ln k. So c is substituted with ln k. So in this case, you can actually further simplify your answer. Recall back basics of ln. We visited it during tutorial in the last week's tutorial. So ln a minus ln b plus ln c. Right? So ln a minus ln b, so over x minus 1, plus ln c, so multiply by k. So you can summarize your answer as this. And when you write ln, please do not forget to put the modulus, as that's how a ln function should be written. Now we will look at another example, which is integrating x over x squared minus 6x plus 9. So for this question, before you start, like semester 2, you have to actually study the power of the function. So you have x over a quadratic function, so you can't perform a polynomial division here. But what you can do is you factorize the denominator. So you get x over x minus 3 squared. So you can't integrate this directly. So what you need to do here is you need to determine the partial fractions for this function. So it will be x over x minus 3 square equals to a over x minus 3 plus b over x minus 3 square. Once you perform the partial fraction calculation, you will actually arrive to your answer of a being 1 and b being 3. Please work out the partial fractions on your own. Next step you need to do is you integrate each of the term individually. So integrating 1 over x minus 3 will give you ln of x minus 3. Integrating this is a normal integration function. So you will actually arrive to negative 3 over x minus 3. So you treat this as 3 multiplied by x minus 3 bracket negative 2. So you can actually negative 2 plus 1, you become x minus 3 power negative 1. So that's what went to the bottom. And you will divide it with also with negative 1. So that's why the plus became a minus here. Okay, this is applying a x plus b to the power of n formula. Okay, and plus c, of course, because it's indefinite integral. Now we will look at the third example when it's integrating 1 over a cubic function. So your first step here will be trying to factorize the cubic function. So your skills of polynomial division here are very important. So you need to guess your first root. So you can guess your first root, probably it's one, a small number like -2. So if I were you, I'll guess x as 1, and I substitute it in and I get a 0. So I'll be very sure that x minus 1 is one of the factor. And then you can perform polynomial division, dividing x cubed for x squared plus x minus 6 with x minus 1, and you get a quadratic, and then you further factorize this. So this is the manual way, or you can just easily use your scientific calculator and factorize this function, and you will get this as your answer. Okay, and your next step will be, of course, to determine the partial fractions. So please work out how to determine the partial fraction. It will be 1 over x minus 1 plus times x plus 2 multiply x plus 3 equals to a over x minus 1, b over x plus 2, and c over x plus 3. So please work out the partial fractions. Once you work out the partial fraction, you will arrive to a as 1 over 12, b as -1 over 3, and c as 1 over 4. So once you get your ABC, so you have successfully converted your single function as a partial fraction function. Your next task will be individually integrating this. Obviously, all three will give you ln. So it will be 1 over 12 is a coefficient. So leave the 1 over 12 alone, multiply by integrating 1 over x minus 1, which will give you ln x minus 1. Same goes here, minus 1 over 3 is the coefficient, and it will become ln x plus 2. Plus 1 over 4 is the coefficient, ln of x plus 3, and don't forget your c because this is an indefinite integral. Next, you can actually substitute c as ln k, and you can actually merge the functions together using the ln law. So ln, so whatever is added, you actually multiply it at the top, and whatever is minus, you put it at the bottom. So as you are aware, 1 over 12 is actually the index for x minus 1. So you can write x minus 1 to the power of 1 over 12. So the k is there. So ln k multiplied by x minus 1 to the power of 1 over 12. And x plus 3 to the power of 1 over 4. And whatever has a negative, it will go to the bottom. So it becomes minus x plus 2, so you put it as dy x plus 2 to the power of 1 over 3. So finally, you can write your answer in this way using the logarithmic law. Now we're going to look at the fourth example, which is find x over x squared plus 4 integral of this. So what we need to do here is we need to look at this function. So there are two ways you can solve this. You can either use substitution, which you learned in semester 2. So you can take the u as the denominator, x squared plus 4, and du dx will give you 2x. So then you can substitute in and you will get the same answer as given in this example. Or you can actually use the approach of whenever you differentiated ln fx, the result was actually f prime x over fx. So now, in return, when you actually integrate f prime x over fx, you should get back ln fx. Okay, so these are special forms of integration. So integrating f prime x over fx with respect to x should actually give you ln fx. So in this case, we can write this in this form. So because we are aware that differentiation of x squared plus 4 is actually 2x. So to modify it, we can actually write a half in front here so that it's the same as the question. Okay, so here we have f prime x over fx. So this one should give you ln fx. So in this case, this becomes half multiplied by ln fx, which is x squared plus 4 plus c because it's an indefinite integral. Now we will look at the fifth example, which is a linear over a quadratic. So for this question, we cannot perform polynomial division. So we have to find a way to simplify this. So we can't divide, we can't actually factorize the denominator. So the only last resort left is to actually split it up. Because it's x plus 3, so it's the same as splitting it into x over x squared plus 4 plus 3 over x squared plus 4. So when you split this is then it's possible for you to actually integrate this function. So in this case, x over x squared plus 4, you can actually use it from the previous example number 4. It's the same question. It splits up into same as question number 4, which we discussed in the previous slide. So you can modify it. You can use the f prime x over fx approach. So you will result in the first part in terms of half ln x squared plus 4. And next, for the second part of the function, it is similar to 1 over x squared, a squared plus x squared. So it's similar to inverse tangent. So we can modify it, we can bring the 3 out. It's as if it's integrating 1 over 2 square plus x square. So your a is 2. So it becomes 3 over a. The 3 is already existing there. So it should be 1 over a. So it becomes 3 times 1 over 2 becomes 3 over 2. Because this is 1 over a square plus x square. So it becomes inverse tangent x over a. So your a is 2 here. So it's x over 2 plus c because it's an indefinite integral.